This is fosfomycin, a broad-spectrum antibiotic that is active against a wide range of bacterial pathogens, including multidrug-resistant strains. However, many bacteria, including priority pathogens such as Klebsiella pneumoniae and Pseudomonas aeruginosa, have become resistant to this antibacterial agent. This happens because the bacteria produce an enzyme called FosA that deactivates fosfomycin. The crystal structure of FosA, with a ligand named ANY1 that binds to it, is available in Protein Data Bank. This opens the opportunity to perform in silico screening to find agents that can inhibit this enzyme and subsequently restore the power of fosfomycin. By using structure-based and ligand-based drug design techniques, the screening is conducted using Schrodinger software against databases of drugs that have been approved clinically, obtained from Drug Bank. The results show some popular drugs with fantastic docking scores that may become promising FosA inhibitors. These include some antibacterial agents from sulphonamides class. Interestingly, drugs from non-antimicrobial classes also appear on top of the list. For example, proton pump inhibitors such as omeprazole and angiotensin receptor blockers such as losartan. Combining an antibiotic with another drug that can prevent inactivation by bacteria is a promising approach to improving the antibacterial efficacy. Long ago, this approach successfully restored the effectiveness of amoxicillin when it is combined with clavulanic acid, a combination known as co-amoxiclav, which is still effective to combat many infections today. The next step of this computational screening is to proceed to in vitro antibacterial testing. This will confirm the improvement of the antimicrobial effect of FosA inhibitor candidates in combination with fosfomycin. Further design and synthesis of potential FosA inhibitors is also considered for this study.